Good afternoon, everybody. 2 weeks ago, NASA made history once again. We conducted humanity's first planetary defense test. And we showed the world that NASA is serious as a defender of this planet. And we captured the attention of millions of people around the world in this test. And that's because DART, as we call it, it felt like a movie plot. But this was not Hollywood. Last November, just before Thanksgiving, a Falcon 9 carrying NASA's first planetary defense test mission launched from the Vandenberg Space Force Base. And after a 10-month journey, millions of miles, NASA successfully crashed a refrigerator-sized spacecraft into the asteroid Dimorphos, 7 million miles from Earth, and it came in at 14,000 miles an hour, and it was a bullseye. But why would NASA do something like this? Well, if an Earth-threatening asteroid was discovered and we could see it far enough away, this technique could be used to deflect it. And so today, NASA confirms that DART successfully changed the targeted asteroid's trajectory. Now, how do we know that? Well, prior to DART's impact, it took Dimorphos 11 hours and 55 minutes to orbit its larger parent asteroid, Didymos. Since DART's impact, astronomers have been using telescopes on Earth to measure how much that time has changed. And now the team has confirmed that the spacecraft's impact altered Dimorphos' orbit around Didymos by 32 minutes and therefore successfully moved its trajectory. In other words, DART shortened the 11-hour and 55-minute orbit to 11 hours and 23 minutes. And it moved it in another location. And that has been confirmed by the telescopes. It was expected to be a huge success if it only slowed the orbit by about 10 minutes. But it actually slowed it by 32 minutes. Dr. Lori Glaze and the DART team will explain more about how we confirm that. Now, this is a watershed moment for planetary defense and a watershed moment for humanity. And that's why it was fitting that DART was an international endeavor. Science benefits humanity. This is a unifying mission. And thanks to Italian Space Agency President Giorgio Sacoscia, I thank him for his partnership. All of us have a responsibility to protect our home planet. After all, it's the only one we have. And this mission shows that NASA is trying to be ready for whatever the universe throws at us. I believe that NASA has proven that we are serious as a defender of the planet. I want to thank you, Gina. Back to you.
Thank you, Administrator Nelson. We'll take another question on the line.
Marvin, your line is open. Please state your affiliation.
Hi, good afternoon. My name is Marvin Marshall from the Nighttime News Space Report here on Twitch.tv. This question is whoever wants to answer this. With the data that we received from this mission, how does this scale up and to what size? would this mission give NASA now the confidence to send, a whole colony or swarm of these darts up there? And are we going to have any on standby? We appreciate all your hard work, and congratulations again on a successful mission.
I'll start it and pass it to you. So we have a physics understanding of how impact should scale with size of target and size of impactor and velocity of impactor. If we are ever in a situation where we have to actually deflect an asteroid, we'll want to look at the situation very carefully, because any such event would be very situational. It would depend on the orbit of the dangerous asteroid, the nature of the asteroid. We would want to find out as much as we can about it, the accessible trajectories, how could we get there, how soon could we get there. All of these things play in before you can even begin talking about, well, should we use one large impactor or several smaller impactors? Is a kinetic impactor really even the best choice at all? Among the things that you would want to think about is if it's a relatively small object, but you have to make a large deflection, you might not want to do this with a single impactor because you might accidentally break it, something we don't want to do. Breaking an asteroid is not really the best way to defend yourself from it, because then instead of having one large object heading for you, you have a lot of little objects heading for you, and that's not better. So how to deal with a single situation is going to be situational. Now, how do you turn that into a decision of what kind of ready-to-go capability you want to have? That's more than a science question, more than an engineering question. It's really a policy question and governmental question. So I'm going to pass to Lori for that one.
Well, I'm actually going to go back to Nancy's statement a little while ago, that more important than which asteroids can we defend ourselves from with this technique is we need to know how, when. We need to find them, and we need to identify them. We need to characterize them. As she said, time is the single most important factor in being able to implement any technique for defense.
Excellent. Thank you so much, everyone, for participating, especially our speakers here at NASA headquarters, and also Mr. Giorgio Sococha, who is joining us on the line, and media who came to attend here today. For more information about the DART mission, you can go to nasa.gov/DART, and also follow us on social media. For additional media questions, if you did not have the opportunity to ask questions either in the room or on the phone, please follow up with Josh Handel, who's here over there, and he'll be happy to answer any questions before your deadline. Thanks, everyone, and have a good rest of the afternoon.